Hello everybody, I am Ben from Team Panic, and I've been fighting robots now for quite a while. And in that time, I have accrued a whole mess of 3D printed parts. So a lot of the parts that are on here, this table are kind of, some have been in fights, some haven't been in fights, some like this were literally just a PLA prototype before I printed an ABS version. And then these are mostly completed things that came off the printer fine. In that time, I've also had a whole bunch of parts that failed on the printer, created spaghetti, came off the printer and were immediately too small, so they got scrapped and tried again. And I thought it was time to try and do something with all of this plastic junk that I've accumulated. So I'm gonna try and turn these into plastic sheets and then hopefully, maybe, create another version of our cheap combat robot we made last week, but this time using some better electronics and also using some recycled PLA, maybe some ABS. I don't know how much ABS I've got saved up, but we're going to try and make our own sheets of material and then use those sheets to create a combat robot. So the first thing to do is going to be to separate all of this stuff into its colors, and then yeah, we can try and chip it down and melt it. Let's get going. It was at this point that things started to go wrong. Turns out that blenders are not really designed to chop up plastic in big quantities like that. Basically, I melted out the connector piece between the base and the actual blender body itself. And I had to 3D print a replacement part. So we've now got a 3D printed part breaking 3D printed parts, which is kind of cool, I think. But I instantly, almost instantly, started to melt the new part as well. So what I'm having to do now is do this really, really slowly. Basically, I'm throwing some parts in and I'm pulsing it like half a dozen times and just leaving it for like an hour to cool down and let everything kind of mellow out, and then I'm pulsing it again another half dozen times. This means that while the stuff that I started breaking down early is small and fine and really quite broken down, the stuff that I'm doing now is still quite big and chunky, and I'm really just hoping that having the toaster oven up quite high is going to make everything form into a nice molten glob that we can then form into a plastic sheet. So, having said all of that, let's actually get the toaster oven out and give this all a whirl, shall we? So the second lot's kind of underway at the moment, but that was my first time messing with molten plastic like that, and it was interesting because I had grease-proof like baking paper in there, and it stuck to that pretty well actually. I found that I had to kind of let it cool to a certain temperature and then it would just peel off slowly, but even then you still had to kind of like pick at the edges constantly to get the thing to actually shift and move. So we had that big blue and white blob, and I've added some more white to it, so hopefully we can get a bit of a bigger thing. The idea from here was to sandwich the plastic into some baking trays and then clamp the baking trays down to form a nice flat sheet of plastic. So let's take a look at how this goes. Disastrous fail is how that went. Yeah, so the clamps that I have weren't deep enough to get into the baking tray. The buffers I had inside the baking trays weren't deep enough or weren't tall enough to get around that. And also the baking tray like bent in the bottom and the top, like it bowed out, which is not good. So I jammed all of the plastic back into the toaster oven so that we can kind of, melt it all back out again and clamp it a different way. This time I was thinking we'd just use straight wood. Once again though, the wood did also bow. Even though that's 12 mil thick, it's still bowed with the clamping pressure, mostly because the clamps don't get to the middle. So I think to do this properly, I'd really need to make some form of like actual press that has an even pressure across the whole surface. That would help a lot here, but I wasn't thinking about that, so we got what we got. I did end up clamping some extra metal around the edges to try and help the bow, but I think by this time the damage had already been done. And this is what we ended up with, which is an interesting piece. It is in no way flat. It's kind of thinner at the edges out here and then thicker in the middle where it bowed. It is an interesting thing though. It's rock solid, which is great. So we've made some form of plastic. And realistically, I'd need more tools to make this usable. I would need at least a thicknesser to kind of plane out the middle section and get it all flat and actually usable as a piece. So considering this was my first ever attempt, I'm not too unhappy with it. I'm not sure how well it's going to show up on camera, but there are some kind of dirty marks around the bits and pieces, which I'm not sure if that's dust from the outside area I was doing this, or if I burnt the plastic, or there was impurities in the plastic. Something's going on and it's not a perfectly clean piece. But as a first attempt at messing around with molten plastic, I'm actually pretty happy with that. So yeah, the next thing I tried is, if you've ever 3D printed anything, you know that you just kind of end up with swarf all over around your printers. They're like things that have gone wrong, like pasta printed things that have kind of fallen over on the print bed. You've got like your little rafts and brims and bits and pieces just kind of scatter around your printer, unless you are clean and, you know, whisk all of those away. I decided to try just a giant ball of that. And rather than do what I did before and knead the colors together, just straight out of the toaster oven and clamp it immediately. And this worked a whole lot better. This is way more uniform than the massive piece. And this massive piece, I would estimate kind of 6 to 8 mil thick, somewhere around there. Kind of, especially in the bulge, it's like about 8, maybe 9 mil thick. This guy is a lot more uniform across the surface, and I think kind of 3 to 5 mil thick, which is a lot better and would actually be easier to make a combat robot out of. Also, it just looks really, really cool. Just the crazy colors and combinations of things that I got. The only thing I'm thinking about is maybe I won't cut this one down yet, and what I'll do is I'll stick it back in the toaster oven at some point and just add a whole bunch of extra plastic around the edges to kind of fill in all of these gaps and things that I've got going on here, because yeah, at the moment the only real usable surface area is kind of like a banana shape through the middle here where I've got a decent amount of plastic, and I'm not sure that's going to be enough to cut everything out. So with this being successful, I decided to try again with the blended pieces of plastic, but this time just lay out a thin sheet of them, and once again, no kneading or anything, just straight out of the toaster oven and into the clamps. And here is where we came to, which this guy is definitely the best piece that I have made. It's a bit of an irregular shape around the edge, but it's a fairly uniform thickness, and it's got a lot of surface area there that we can use to make a combat robot. It worked pretty well. The only thing I will say about this is, once again, it kind of browned a little bit on one side. I have a feeling that's because this one I actually over melted. I left in the toaster oven for too long, and I had the toaster oven up too hot. I think I left this for maybe 6 to 7 minutes, and the other ones again more kind of like 4 to 5 minutes. A lot of this stuff was just done by eye. I'm really not an expert on melting plastics down and all of that kind of stuff. So this was just a bit of a, yeah, it's all just a bit of an experiment. But this guy worked really, really well. Now, off the back of that, I did try again with a different piece. This one I didn't film, but here is the final product. It's not as good. So the problem with this is I didn't put down enough plastic. I had some discs of red that you can kind of see through this piece, and they shrunk as they got hot. So there's some big holes, especially kind of like through the middle here, where the red has kind of shrunk away from the white plastic, and it's left big gaps. So once again, it's okay, but it definitely needs the same treatment as our big noodly guy. We just need to heat these back up and add a bit more plastic to them just to kind of cover those holes and fill those gaps in. So this is an interesting process. It's going to be something that I'm going to do again, and I'm going to have to learn more about. But I think before I get to that point, we are going to build a press of some form, or buy a press, or I don't know, work something out that will mean that we can actually get more uniform shapes out of this stuff. Because yeah, the double clamps on wood situation is not the best, and it's not really working out all that well. So anyway, now we're going to cut this guy up, and we are going to attempt to turn this into a combat robot. Or actually not, because this is the part of the video where I completely changed my plans. Because originally I was just going to take the template from the super cheap robot build video, slap it down onto this piece of plastic, do some cuts, do some dremeling and some drilling and stuff, and make another robot out of this. But this is going to be a very similar process to that last time. And realistically, that's not what I'm going to use this plastic for ever, I don't think. I mean, I might do that if I ever work out how to make HDPE or something. I might make armor panels and bolt them to a combat robot, but I don't think I'll ever make a panel of plastic again and then bend it into combat robot shape. So I was thinking, what do I want to do with some flat sheets of plastic? And one thing occurred to me was my Sawbot Microblaze, which I figured I could cut some saw blades out of this new plastic sheeting material and yeah, try that out, because in a previous video we tried out a 3D printed plastic saw and this actually worked surprisingly well, but it is of course a 3D printed thing. So I'm thinking that this stuff that's actual like pressed welded together material or like fused together material is actually going to work a little bit better. The only difference here is that this is a 5mm hole in here and the hole saw I have is a 6mm hole. So I do need to have some little 3D printed shims to make it all fit properly, but that's okay, we can totally do that. Now, these two sheets that I have here that I have cut some experimental saw blades out of, these are PLA sheets, so these are PLA saw blades, but the same process that I've gone through to make these PLA versions, I can do with ABS. So I can actually make solid ABS saw blades and not have to sit around for hours and print them, which could be quite cool. So I'm going to bolt one of these on here and we're going to give that a test and see how that goes. Hopefully well. So that was unexpected. Check it out, we've fused the duck to the blade, which is hilarious. And the motor really struggled after we did this. It really could not hack the fact that we'd stuck the duck to the blade. So this is interesting. It does turn out that the shape really matters on the 3D printed version. Even though it's very slight, we do have a lip and an edge. On these, I didn't have that. So to actually make these proper saw blades, I'm going to have to find a lathe and kind of sneak the edge down and give it a chamfer on the sides so that it actually becomes a blade and doesn't just kind of friction itself and weld itself in place. Because that is exactly what we've done here. There are a few kind of marks that I'm not even really sure are going to show up on camera too well that it did make, but it would be a lot better with that chamfered edge on it. But I think this is something that I could do in the future with these plastic sheets. Now I'll probably have to do this again with ABS, because this here is an ABS chassis that is an extra chassis, and I tried to hit it here on this bolt hole and you can see it's not really done anything at all. So an ABS version of this would actually work really well. I might maybe go back and do the cardboard idea with these PLA sheets, considering that, yeah, these PLA discs aren't probably the best idea, but that will have to be at a later point. I'm not too unhappy with that. It worked a lot better than I was expecting, to be honest. So yeah, there you go. This is something I will do again in the future, I think. Play around with some more recycling techniques and things, because I've learned a lot during this. I've definitely need to improve my equipment before I do it again so that I have a better result, essentially. Anyway, I think that's going to be it for this video. I am going to remove this saw blade though, because I want to see if I can keep it attached to the duck the whole time and just kind of leave this as a little trophy with a saw blade mounted out the back of an old duck chassis. I really do need to rebuild this guy and put that down as a loan bot at some point. That would be quite cool. It was originally a thwack bot, which, yeah, it worked. It worked okay. It needed fast drive, and yeah, kids like their fast drive, so there you go. Look at that. Oh, that's so cool. Yep, that's stuck. I mean, you could probably get that out if this was in a competition type situation. You could probably remove that with a blade of some kind, but for now, it's pretty stuck on there. So yeah, there you go. All right, I think that is where we're going to leave this one. I hope you guys have enjoyed that one, and I will see you in the next video.